So folks, let's pick up where we left off. We now want to find a general solution to this non-homogeneous equation. Well, from above, we've already shown what the solution is to the corresponding homogeneous equation for this. So from number 2, we know that this homogeneous equation has solutions c1 e to the minus 2 plus the square root of 6 times t plus c2 e to the minus 2 minus the square root of 6 times t. And if you didn't see part 1 of these videos, all I did was solve the corresponding characteristic equation here. So that is, we solved r squared plus 4r minus 2 equals 0. We found the roots to the characteristic equation. We had to use complete the square. And then we had to make some comment about the solutions being linearly independent before we could say that they gave a homogeneous, or before they could say they gave a general solution to the homogeneous equation. So now that we've got that, we need a guess at yp, and that's really the heart of the method of undetermined coefficients. So previously, we looked at the structure of the forcing function on the right-hand side there, and we said that whatever our guess is, it needs to incorporate the structure of the function that we see and all successive derivatives of that. So if I come down and take a look at this, here our forcing function is t squared plus 3. And any guess that I give needs to take into account that structure right there. So you might think at squared plus a constant b would work, but it also needs to take into account all successive derivatives. Notice that if I take the derivative of this quadratic, I end up with a linear function. So my guess needs to allow for some coefficient in front of a linear function. So my guess in this case is yp equals at squared. And you would think maybe just plus a constant, but I also need to account for the fact that when I take a derivative of t squared, I'll get a 2t, and so I need to have a coefficient that allows for a linear term to show up in my guess. Just like we did before, we'll take two successive derivatives of this. Here we'd have 2at plus b, and taking the second derivative, we would get 2a. And now what I'm going to do is I'm going to plug those guess terms into the original non-homogeneous equation. So we've got 2a plus 4 times 2at plus b minus 2 times at squared plus bt plus c, where this was my guess, yp, this was its derivative, yp prime, and this was its second derivative. And we're hoping that we will be able to find coefficients so that the right-hand side, or so that the left-hand side equals the right-hand side, which is t squared plus, here I'll emphasize by putting a 0t plus 3. So just like we were able to do before, we can build a system of equations. Notice that I get one equation would be 2a is equal to 1, because I only have, oops, that's not true. So let's be a little bit careful getting those coefficient equations. Let's see here. If I were to regroup all the terms, I would have minus 2a parentheses t squared. Then I'll group together all the linear terms, and I've got, looks like plus 8a, because that's a linear term right there. And I've got a minus 2b linear term, so my 8a minus 2bt. And then if I group together all the constant terms, I would have plus 2a minus, plus 4b minus 2c. And all of this needs to equal, let me scoot that over, sorry folks, let's scoot that over here. That needs to equal t squared plus 0t plus 3. And so making a positioning argument that we've made many times before in this class, we get that minus 2a needs to equal 1, where the coefficient in front of this t squared term needs to equal the coefficient in front of this. My second equation is that 8a minus 2b needs to equal 0. And my third equation is that 2a plus 4b minus 2c is equal to 3. Now again, folks, sometimes I may need to pull out all the stops and solve this system of equations, maybe using matrices or Cramer's rule or some other technique. But in this case, it makes sense to sort of independently solve the first equation, plug that result into the second, find the results for a and b, and plug them into the third. So this ladders very nicely. In this case, we find that a is equal to minus 1/2. So if we were to plug that into the second, we'd have a times minus 1/2 minus 2b needs to equal 0. That gives me minus 4 needs to equal 2b, or b needs to equal minus 2. Taking those two solutions and plugging them into the third gives me 2 times minus 1/2 plus 4 times minus 2 minus 2c needs to equal 3. So let's see here. That gives me negative 1 minus 2 minus 2c needs to equal 3. That gives me negative 3 minus 2c needs to equal 3. Or let's see here, negative 6 is equal to 2c, or c is equal to minus 3. Whew, that was rough, but it wasn't the worst thing we've done in this class. At this point, we found a, b, and c. Those were the undetermined coefficients from our guess at the particular solution. So now we know that our particular solution that will satisfy this original non-homogeneous ODE right here is this quadratic, negative 1/2 t squared minus 2t minus 3. And if you were to take, you could verify it, but if you were to take the two successive derivatives of this and then plug everything into the original ODE, that it would solve it. So how do we then represent our overall general solution to the non-homogeneous ODE? It is going to be our homogeneous solution, the solution to the corresponding homogeneous equation, c1e to the minus 2 plus the square root of 6t plus c2e to the negative 2 minus the square root of 6t. Careful, that's a minus sign there. And then plus our particular solution, which is this quadratic right here. So again, here we've represented it as the corresponding solution, general solution to the homogeneous ODE, plus one particular solution to the non-homogeneous ODE, and we give our general solution then this way. So folks, I hope that video was helpful. What we're going to see in subsequent videos is what to do with various right-hand forcing functions for these non-homogeneous ODEs, and it will get a little bit trickier as we go along. But never fear, we'll take care of it, and I will see you in the next video. Thank you. Hey folks, really briefly, I realize there's a couple errors here, or just one error. When I multiplied 4 times negative 2, that should have given me negative 8. So that should have been a negative 8 there. And that would have changed everything in that we would have gotten minus 12 here, or, well, let's just follow through with the error. This would have given me minus 9 here, which would have given me minus 12 is equal to 2c, or that c is equal to negative 6. And so this should have been, a minus 6 here, folks. And then that would have been a minus 6 here. So sorry for that confusion, and I hope that that didn't interrupt the flow of anything. Thanks.